Charging is on. Is the voice clear? The problem is it is very hot here. I have put fan. Because of fan, some light sound will come. If the fan is, if I switch off the fan, very hot inside. Is voice clear? That fan sound, hope it is not disturbing. It is clear and start. That fan sound, I don't think it is that much disturbing. If I switch off the fan, difficult to take the class here. Okay, I can open the window. Okay, I will start now. See now, make a note. Important note. Everything is ready. Last time I told you how to find single load P, one moment this way, one moment this way. That is for raft footing. Same principle for combined footing also. See, there 4 columns are there. It can be 6 column also. Here combined is, even that also is combined footing only. But usually people call, when 2 columns are there, combined footing. Usual name. Okay, now we will start combined footing. See, very important. Remember, we start combined footing. This is a very popular combined footing for 2 columns. That's all. If it is more than 2 columns, we will call raft. See, if more than 2 columns are there, 4 or 5 or randomly spaced, it is called raft. We will call raft or mat. Now, it is very important. See, there are 2 types of combined footings. Same, 2 columns. One is only slab type. 2 types are there. There are 2 types. Namely, one of them is only slab type. Only slab type. Second one is slab and beam type. Slab and beam type. Now, remember, at present, most popular is this one. That is fully outdated. It is outdated. Textbooks all you can see. Academic they give question. Practically outdated. So, I will not waste too much time on this design part. But I will tell the design principle. I will tell the design principle here with the diagram. Then, later, when I go to software, at that time, yes, we will design only slab type, the most popular, and also we will design what? Slab and beam type. But at that time, principle I will not tell. I will tell, refer to earlier class. So anyway, this is in YouTube. Therefore, this will not be deleted. Earlier classes all for ETAB batch, ETABS&SAFE batch, I am going to delete. Maybe it will still be still there for at least 1 more month, 1.5 months, because some newcomers will be there for software part. For them, recordings I will give for them. So I will give deadline time for them. Then one fine day I will announce and delete all the classes of ETABS&SAFE till we reach column. See, starting classes, all what? Structural knowledge, section forces, equilibrium, so many things are told for you. Some logic, then beam design, SFD, BMD, how to draw, axial force, shear force, bending moment, that those diagrams, and then single in post beam, WA in post beam, how to find AST, how to design for shear, then one-way slab, two-way slab, all those things. They are in this Zoom. So, the recordings are still there in the batch, not for general public. For those who are in the batch or group, recordings are still there. I will give a warning later. Now time has come to delete it. But columns and footing, fortunately for you, it will be always there. Why? It is in YouTube. So later, when I make model of the combined footing in software, one class I will take up, once I will take up only slab type, most popular. Then I will tell, just for information, slab and beam type. Then design will be done by software. But you should understand what is the principle. At that time, what I will do is, I will briefly tell, see, when beam and slab type is there, I will tell it later now. After I fix the footing dimensions, I will tell that one. There, beam, column will rest on beam, below slab is there. I will tell slab is bending as a one-way slab as cantilever, fixed at the face of the beam. The beam is subjected to longitudinal bending. See, this way, like two columns here and upward load from transferred from the slab. It will be like this almost. Beam design will be like this. See, then same except the BMD. Okay, therefore this I will tell. Now, only slab type is the most popular. Nowadays, wherever you go, people go for only slab type because beam and slab type construction delays. You have to set centering for beam, etc. And it is found that beam reinforcement comes more. So to avoid that one, nowadays wherever you go and see, they even see isolated putting slab only, combined putting also only slab. I will tell the sketch here. Beam and slab type outdated. Still I will explain. Rock putting long back in the theory, if you see books all, even for rock putting you can see beam and slab type. Completely outdated. They will provide only slab. If required, thickness will be increased. Then those all will discuss in the design principles. Now, first what you do is right here. See, only slab type will be like this. See, I can show roughly here. One column here. I am not good in 3D views. I am not good in 3D views. I somehow manage. See, one column here. One more column here. Don't cut. This is cut actually. Okay, cut is not required. One more column here. Then this is only slab. I should go a little this way. How? I should go little this way. Or no? How this or this? Okay, okay. Yes. This is only slab type. See, column load transferred here. From below, pressure will come. From below, pressure will come. This is only slab type. Tell me, fully clear? This will discuss in detail. Because design means complete. But one thing, SFDBMD I will not explain. This is only slab type. Okay. Now, I will go for beam and slab type. I am very weak in 3D sketch. Okay. I will manage here somehow. So very difficult actually. 1 minute. Somehow I will manage. Okay. What to do? As much as possible I will try to manage. Then one column here. See, column will rest on the beam. One more column somewhere here. I should write this way actually. See. Okay, no problem. Who bothers about this one? Then I have got difficulty of closing here. The closing I can't do. See, these are the projection of the slab. This is the beam. Beam. Here column is, see, column directly rests. Column became column. Okay. Directly rests on slab. Here column rests on beam. Beam. And below beam there is slab. And slab is in contact with soil. Contact with soil. See, here closing, I am little weak to do it. I don't know. Some people beautifully they do it. Don't see that. Cut. Okay. Now, here what will happen is, see, here the slab will undergo lengthwise bending and also widthwise bending. Anybody can tell? Lengthwise bending full. See, correctly understand. I will not hurry. See, this is slab. My two fingers are the columns. See, pressure is coming here. See now, it will undergo lengthwise bending and also widthwise bending. Lengthwise bending will be, see here. See, lengthwise bending is for entire length. See, lengthwise bending will be how? More usually it will sag here. This will sag. Central portion due to pressure will, depending on the spacing of the column, if the column is quite wide apart, that will hog. Whereas, if the columns are quite nearby, this will sag, this also will sag, then this also will sag. If the columns are far off, see, if the columns are far off, your BMD on tension side, remember, now you have to draw BMD on tension side. Now, SFD BMD course, I put sagging positive. That is for the course. Now, ETAB and SAFE, I told you long back, BMD on tension side. See, this will sag. So, tension is bottom. It will come this way, this will come this way. Now, if the columns are wide apart, beam will bend like this. Then, sagging, hogging, sagging, bottom steel, top steel, bottom steel. This is what? For the slab, lengthwise bending. And, or, if the columns are quite closer, then pressure will be there here, then this will, see, BMD will come, it will come this way. Only sagging, full tension at the top. These all I told you in the SFD BMD class. At that time, I invited the people from ETABS and RCC with a note there. Attend the class, useful for you. Because later, when I go to combined putting, SFD BMD, I am not explaining. In the course, BSK course, not SFD BMD course. That is that 100 classes. No, BSK course. Of course, I merged it with the SFD BMD course. Class number 101 onwards. Ending part, I think class number 120, I don't remember. There, all these are done. Right now, go through it. I again a warning for you. See, I sent a message only for ETAB and SAFE batch and also for which one? RCC batch. Steel batch and other, one more batch was, one is steel. Which other batch? One steel. For them it is not mandatory. I told that if you want to come, they are all guests only. But RCC people and other one is what? ETAB people, you should go through it. Okay, now, this is bending. This is what? Beam and slab type. This is lengthwise bending. Also, there will be widthwise bending. Widthwise bending will come not everywhere. Anybody can tell where widthwise bending will come? This way. Width, see, it can bend like this. Lengthwise bending over, see, this is the main lengthwise bending. Widthwise bending also will come not everywhere. Only where? Tell me. Widthwise bending will come where? Imagine. Where widthwise bending? Imagine. Where widthwise bending will come? Just imagine. Just imagine widthwise bending. It will not come everywhere this way. Here all widthwise bending will not come. Here also it will not come. Why? There is no support here. Where widthwise bending will come? Think a little and tell me. Where widthwise bending will come? Think a little and tell. Only under the column, correct. So, some portion, some length this side, some length this side, see, it can have widthwise bending. Some length here, widthwise bending. Usual practice is, you consider a distance of D this side, and D this side, and D this side, and D this side. There, it will, this way it will bend. You need bottom steel like this, see, display steel. These all I tell you when I go for the design, because this is the main design you are doing. Practically, this is the design you are doing. Furthermore, not required because this you are designing in the class. Since you are designing, you tell, anyway, I am coming to you later, so get out. Here, class we are not designing. There is a limit. Here, not that way. See, because of presence of beam, anybody can tell, the slab will not bend lengthwise. See, complete length for the slab, there is beam. See, therefore, tell me, in this case, the slab will bend only, how? See now, in this case, the slab will bend only lengthwise or widthwise. slab will bend only lengthwise or widthwise. For beam and slab type, slab, this one here, see, this is the, think a little, this is the slab, this is the beam, columns are above the beam, see now, due to pressure, you can see here only what I am showing. The slab will bend only widthwise or lengthwise. Only widthwise. It is designed as a cantilever. See here, designed as a double cantilever. So this is the steel for the slab. This way steel. So this way is distribution steel. Slab cannot bend this way. But how about the beam? The beam will undergo lengthwise bending, like this lengthwise bending. Here lengthwise bending for the slab, there lengthwise bending for the beam. Okay, there stirrup, see reinforcement, top and bottom will be there, stirrup will be there, this way it will continue. So this I will tell you principle, not now. When after I finish the fixing of the footing dimensions, I will give design principle for both slab type and beam type. Then rigorously in the class we will decide the real practical requirement of slab type. Beam type I will tell you, even steel I will show you, then I will tell. We will model in SAFE and see the result there and let the SAFE do it. That's all. Otherwise our class will never end. Clear now? Clear or not? Clear or not? There is a reason for telling this one now. There is a particular reason for it. Clear concept? I will give the design principle again. Don't worry. Okay. Now, right here, irrespective of whether it is only slab type, which is the most popular, or slab and beam type, whatever is that is above the slab, correct? It is for the RCC design. Whereas irrespective of whether this case or that case, I will remove now, irrespective of this case or that case, 1 minute, here, irrespective of what, this case or that case, full I will remove and go to next part. That should be completely understood now. See, sometimes people will tell, design to understand, it is done very in detail. You should think that way. Once you understand, this is the time. If I want to finish the course very earlier, I need not tell all these things. I can finish very fast. Then some will tell, oh, fast course. When you covered all this basic, you should understand correctly everything for statical design. Therefore, see, little. Now, very important, don't forget now. See, I'll write here. Irrespective of whether it is only slab type, or slab and beam type. The contact of footing with the soil is for 1 minute now. I should have given something for you, forgot now. See, only slab type, I will write here. Only slab type. I will take this as L1, this as L2. Slab and beam type. Once again I draw. Okay, done. Leave it. Slab and beam type. Okay. Column. I will call this as L2, this as L1. Therefore, it is all upper side. If you go inside the soil, suppose you go inside the soil and look up, can you see the beam? Tell me. If you go inside the soil and look up, can you see the beam? First, suppose you go inside the soil and slowly remove some soil and see this one, if possible. Can you see the beam? Can you see the column, that beam, or beam type or slab type? Can you make out? No. Suppose you dig from somewhere and come, how you are coming, I don't know. Suppose you go below the footing, see below the footing and look this way, somewhere there. You cannot make out whether it is beam type or slab type. You are seeing a rectangular contact area, contact of footing with soil is what? A rectangular area L1 into L2. Yes or no? Rectangular area L1 by L2. Just tell yes or no. Rectangular area L1 by L2. Fast. You cannot make out beam type or slab type there. Yes. Therefore, fixing the footing dimensions in plan. Therefore, right here. Therefore, fixing of footing dimensions that is L1 and L2, that is in plan is based on usual. What is usual? Tell me. Usual means PG maximum should not exceed SBC of soil, and I told you PG minimum should not be negative. Sorry, further I am not telling. Clear? PG minimum should not be negative. Remember, in our basic theory should not be negative. In ETABS&SAFE, ulta, their sign is reverse. So there should not be positive. Should not be negative here means should not be positive there. When I go to ETABS&SAFE, I will tell, see, basic study should not be negative. In ETABS&SAFE should not be positive because negative as per our sign is positive there. What is positive for us is negative there. Or you can do one thing. ETAB or this one or software or manual, what is the principle? Footing should not what? Tell me. Or simple words. Should not what? The footing edge should not what? Tell me. Don't tell positive negative. It should not. Single word. Should not. As I told you, don't worry about positive negative. Should not. This much difficulty to give the answer. Should not get lifted up. Should not get lifted. That's all you want. Here, lifting is prevented if the minimum pressure is positive. In ETABS&SAFE, lifting is prevented if minimum pressure is negative. Here you do not want negative pressure. There you do not want positive pressure. And once again, if you go to STAT Pro, reverse. STAT Pro is like our class because our sign is pressure, compression positive, tension negative. In ETAB, reverse. Tension positive, compression negative. Anyway, that I will tell you in the ETAB class. Don't worry now. When I go to ETAB model, I will tell that at that time. Here why I am telling because this class is meant for ETABS&SAFE batch on and also for RCC batch. Okay. Now most important principle, see. What you have to do is, irrespective of slab type or slab and beam type, see, now, this is the footing. This is the footing, 3D view. Plan. Let me put here now. If it is only slab type, the plan will be like this. See, I will remove this one once again now. The plan will be like this. One column here, one column here. It can be turned also. This is only slab type. If it is slab and beam type, the footing plan will be here. See, footing plan. You can see the beam here. then you can see the column. In both the cases, L1, common, L2. Clear? Write both the sketches. Clear or not? Here you can see only what? Column. There you can see a beam. Plan. I am telling plan. In the plan you can see footing this way. The beam you can see line. Then you can see column. Fast. Tell me, clear or not? Why so delay? Oh. Just tell me, clear or not? View. You have to answer fast. Because problem is, I want confirm. Two reasons are there. Main reason, I want see that, I want to ensure that you can hear because of the net problem. Only here. Next Tuesday, I am going to, Tuesday or Wednesday, I am going to Bangalore. So next Saturday, Sunday, class will be from Bangalore only. There, Wi-Fi is there, no problem. This much trouble is not there. Here, what to do? But still, this is the first time happened. Otherwise, earlier all I stayed months together here. There was no problem, if you remember. Okay, now, further, see now. Now, this is the spacing. I will call S. Some symbol required S. This is the spacing. I will call S. Column. Now, lengthwise, this is, I will call PL. This I will call PR. Here I will call, this is PL, this is PR. This way no problem. Tell me. S is the spacing of the columns. PL is left side projection. PR is right side projection from center of the column. This is PL clear, not required for us. This is the clear projection. This is center projection up to center. Okay. Again, this should be clear. Now I will tell you one thing. Make a note. If it is only slab types, predominant bending is lengthwise. How it will be? Sagging and hogging and sagging, or only sagging. If it is beam and slab type, slab will bend as a cantilever. Okay. But beam will bend sagging, hogging, or only sagging. So, therefore, predominant bending is lengthwise, not widthwise. Widthwise, we will check the steel later. So, predominant bending is lengthwise. Therefore, in both the cases, bending and shear, for predominant bending and shear, what shear? One-way shear. If you see, what you can see? You can see a line here. It can be a slab only if it is slab type, or it is a beam if it is slab and beam type. Okay. You can see something like this. And you can see downward loads here. Correct? And you can see upward pressure here. You can see upward pressure. Now, this is your S. This is your PL. This is your PR. Some symbol required for me. PL, PR. Okay, now, do not make PL equal to PR. No. Be careful. Do not make PL equal to PR. A small Excel sheet you can prepare later if you want. But usually people, what they do is judgment. So many people, by judgment, they will decide to create the model, run it, check the pressure. If the pressure comes safe, they will proceed further. If pressure is unsafe or problem is there, they will change the dimension and rerun it. So not a big issue. Therefore, for both the cases, this one. Now, I will remove these two. Why? This is common for both. It is common for both. Okay, now, is this same as, you can write here, is this, does it look same as, does this look same as a beam with the two vertical reaction here and loading like this? But only thing is, here load is down, pressure is up. Here distribution is downward, loading and up. Or tell what this is called. tell what this is called. What you call this one? What you call this one? Name. What this is called? Does it look same or not? Double overhang beam, or this is same as simply supported beam with the double overhang. Of course, couple can be here. Here also couple can be there. Simply support beam with the double overhang. Now, those who are, remember, in the SFD BSK class, I talked about this one. I told them, see, now, forget about, this is not UDL, it is random. Now, make a note. In case the loading is pure UDL, and also, what? If projections are equal, if I remember, I took the projection as, I don't remember, I will take A. A is the projection. Span is L. Then there are three possible BMD for this one. I will draw one by one. I will draw it here as sagging positive. No, I will draw this time on tension side. Okay, tension ulta. If you want to draw tension side, all I will tell you is here. Plus means plot below, minus means plot above. That's all. In the ETAB class, I told. SFD BMD class, I will tell later. You wait for some time. Time being, believe me. That's all. See, now, three BMDs are possible. One of the BMD is, see, this will bend over. This is the BMD. What? Hogging and sagging. Another BMD is rare case, 0 here. One more case of BMD is sagging, hogging, full tension at the top, this way. Now, for this one, your A should be, you compare with L. If you compare AL, total length is capital L. For this case, don't compare L. A should be less than, anybody can tell? L by 4. Here, A should be equal to L by 4. Here, A should be more than total length by 4. Do you remember or not? In the SFD BMD course, in BSK, I had done it. Class number maybe 111 or 112. Go through it. Those who are in ETAB batch, you do one thing. Go to my BSK class. It is in YouTube. There, I started from class number 101. Up to 100 is pure BSK. It is in Zoom app. It is not available. Someone commented recently. I have not answered it. He told, your BSK class, SFBMD, I liked very much. I want to go through all the previous 100 classes. Where I can see. Where you can see is you cannot see. Why? It is in the group only. It is not public. He told that way. If he is listening, I will tell sorry. I cannot give send link of the class to everybody. Why? It is my professional class. So it is not available for public. If he asks further, I will tell next time join the batch. See, I should see my interest also. So he cannot see it. Whatever I give, take it. Okay, now, do you remember this case? Yes or no? Tell me. Do you remember this case? Otherwise, believe me. First. Do you remember this case or not? Yes, good. Otherwise, sorry. Okay. Now, this is ratio of A to L. There is one more thing is there. For see, now keep L quite reasonable. Then there is one more principle. What? One more principle is there that, see, if column spacing is reasonable, if you can give the overhang as you like, not randomly. Sometime you may require more overhang, situation may demand. then this theory is gone. There is one more principle. You can get the BMD exactly like this. See, whatever this M, if I tell AB here and CD here, this is center E, M at A, M at B, M at E. M at A is hogging, M at B is hogging, M at E is sagging. Your this BM equal to this BM equal to this BM is called maximum BM for the entire beam. For the entire beam is minimized. It is made as much as possible. See, now I will tell example for you. If the overhang is very small, just randomly, B and D can come this way. See, huge this way. See, 50, 50, 150. Oh, high BM of 150. Now, if I increase the overhang, BMD can be made 90, 90 and say 112. Oh, better than that one. Why? That time you should design for highest BM of 150. Now your highest BM is 112, or one particular value of A, you can get BMD like this. See, 90, 97, 97 and 97. Oh, this is the best arrangement. By chance, if you further push the column inside, what will happen? 97 will become 115, it will become 115, it will become this. Oh, bad, no. Here, that is the sagging BM equal to hogging BM. Tell me, first of all, I should not tell. I should tell, go and refer the class and come back. But still, I won't tell. Clear now? This principle, remember or not? Yes. For that condition, for a simply supported beam, this is the extra principle I told. See, simply supported beam of span L. L is the span between supports. Between supports. L is the total length. Total length. See, for BMD to be what? For hogging BM here, hogging BM here, sagging BM here. For maximum hogging BM equal to maximum sagging BM, which is the most economical case. Most economical case, because maximum BM is minimized. Minimized. That case, anybody can tell me A should be how much times of capital L. I do not want A equal to how much times of capital L, or first tell me A equal to how much times of small l, or A equal to how much times of capital L. Both are required. Tell the number here. First, A equal to how much times of small l. First, A equal to how much times of small l. Both are required. I will tell you why. A equal to how much times of small l. Okay, tell that only. Capital L, this is secondary. You tell me A equal to how much times of L. No. Where you got it from? Sorry. L by 2 plus root 8. Oh, L by 2 root 8. Okay. It is, sorry. Writing problem. L by, see, A should be 1 by 2 root 8 of L, or decimal point of view, tell the answer, 1 by 2 root 8 of L, decimal point of view. This is wrong. I know it. This is wrong. L by 2 root 8 is wrong. Because I am not getting the answer. See, I don't remember early bidding. Ayo, A equal to L by root 8. That's all. What is the 2 root? L by root 8. See, you forgot. A equal to L by root 8. Pass mark number or decimal point of view, how much? 1 by root 8. What is the answer? What is 1 by root 8? Number, tell me. Number, approximately. Instead of root 8, or tell a number, percentage basis. No, I am asking for small l. Tell the number. 1 by root 8. What is the answer? What is 1 by root 8? Point. 1 by root 8. I told on that class. Our old university pass mark number. I told, remember, when I was studying, pass mark was that number. How much? Tell me. What was the pass mark around 25 years earlier? Anybody can tell? What was the pass mark around 25 years earlier? It is not 40. How much? Tell me. It is not 40. Pass mark around 20 years earlier. People will come and tell me, sir, I want to get that number. Some people will tell, sir, ಕನ್ನಡದಲ್ಲಿ ಏನಾರು ಮಾಡಿ 35 ಕೊಡಿಸ್ಬಿಡಿ ಸರ್ ಅಂತ. Tell me, English, how much pass mark? So many people will tell, the parents will come and tell. Somehow see that he gets 35. So it is almost equal to 0.35 L or 35% of L. Clear or not? That is connecting A with L. Be careful. Connecting A with small l. Clear or not? I will not tell once again. Already told in the YouTube class. You should go through once again. I have done the proof also there. Clear? I have given the proof also there. Here that proof I cannot take. Answer ಮಾಡ್ತಾ ಇಲ್ಲ. If it is clear means I will go to next one. Why only one person commenting? Others are keeping quiet. See, you should comment at least. I think some of them are not knowing. I know it. So many are not knowing. ಹೌದಾ? ಕನ್ನಡದಲ್ಲಿ ಹಿಂಗೂ ಇದೆಯಾ? ಹಿಂದಿಲಿ ऐसा भी है क्या? ऐसा भी है. Okay. That is relating A with small l. Now tell me, relate A with the capital L. What is the number? It is not 0.35. See, if I take this L, this should be around 35% of L. If I take total L, then relation is not 35%. I think around 20%, I think. What is that number? That number is what is the formula there? Who remember that one? Ayyo. Again, I have to put now. See, L, or you can do one thing. A equal to L by root 8. Then you know that A plus L equal to capital L, or A plus L equal to root 8 of what? Root 8 of A should be L, or 2A plus root 8A equal to L, or A equal to L by 2 plus root 8. Correct? 2 plus root 8. See, you are forcing me 2 plus root 8 equal to reciprocal. Yes, 0.207. It is actually 0.207, or you can take A is almost equal to say 0.21 L. So remember now, for maximum BM to be minimum, or for most economical design, condition is if you link A with the small l, it is around 35%. If you link A with the capital L, it is around 20.1%. 21%. Around 21%. Okay. 7 3 21, 7 5 35. Luckily, both are divisible by 7. ರಿಮೆಂಬರ್ 7 1 7 7 2 14 7 3 21 7 5 35. ಓಕೆ, ದಿಸ್ ನಂಬರ್ ಯು ರಿಮೆಂಬರ್. ದಿಸ್ ಈಸ್ ಫಾರ್ ಪ್ಯೂರ್ UDL and symmetrical case. Right here, this is for symmetrical case. Now note, ಈಗ that is for symmetrical case. Now come to combined footing. Combined footing. What happens is, column loads are here. Earlier what I told L now becomes what? Tell me. Earlier what I told L now becomes what? Earlier what I told L, small l, now becomes, I told you just now. You should remember this one now. Write in a paper. That is in SFDBMD chapter. That becomes S. Spacing of the column. Then this earlier called A, now it is called PL and PR. Okay, now PL need not be equal to PR. And upward load, there it is UDL. No, here it can be like this, or it can be like this. Like this. And rarest of rare case, what? Tell me. Rarest of rare case never happens. It never happened. By chance, if the resultant a complete system, when you replace by a load and couple at center, if the couple vanishes, if only load comes at center, rarest of rare case, it never happened in my entire life for practical design. Never happened it for my entire life. Rarest of rare case, it will be what? Tell me. Rare of rare case, it can be what? Then no question of eccentricity. Resultant column load will pass through CG of the footing. Rare case, it never happened so far. Practically, when you go for a different load combination, it is impossible to happen. But rarest rare case, it will be uniform pressure. Okay, now see, now if it is this way, then that theory is not applicable. And also the two column loads are not equal. Therefore, due to that reason also, that theory not applicable. And PL need not be equal to PR. On that basis also not applicable. But overall, it can give a guideline or some rough range. The rough range for PL or PR is what? Roughly or approximately, or for trial section. For trial section, you can take PL equal to PR equal to S into, tell the number. PL equal to PR equal to S into what? S into number. I am linking with spaniel, small l. Tell the answer. PL you can take equal to PR equal to 0.21 L, or you can take 21% of what? What is this? This much I explained. 21%. ಅಯ್ಯೋ, ಅಷ್ಟು ಬೇಗ ಮರ್ತೋಯ್ತಾ? I am linking that with the small l. 21% is for the complete length. ಅಷ್ಟು ಬೇಗ ಮರ್ತೋಯ್ತಾ? The moment I came to write there, I got a shock. 35%. It can be taken as around 0.35 andaju of S. Now use this thumb rule and get PL and PR. But use this thumb rule, get PL, PR. Then use this thumb rule and get PL and PR. Both equal, but don't give equal. Later, see where column load is more. There, give a little more projection. Where column load is less, give a little lesser projection. I will tell you why. Where column load is more, give a little more projection. Where column load is lesser, give a little lesser projection so that your pressure will almost become what? Tell me. You can make pressure almost. Then resultant load will come near and near to center, so that pressure, it can never be uniform. It can become what? Pressure can be, you can make it tended to too much instead of this way variation, you can make the variation lesser. Okay. See, if it is this way, you can try to make something like this. Okay, better. Yes or no? That is, go for approximately uniform pressure. Uniform pressure has advantage. Tell why. Uniform pressure has advantage. Reason first. Because if pressure is uniform, settlement becomes even or uneven. If pressure is uniform, settlement becomes even or uneven. If pressure is uniform, it becomes even. If the settlement is even or uniform settlement, good or bad? Tell me, stability point of view, good or bad? If settlement is uniform, good or bad? It is very good. Uneven settlement creates problem. See, actually, we are considering here basic theory, bending theory. We don't consider settlement of soil. But if you consider soil subgrade reaction, very, very important term. When you go to ETABS&SAFE, when you create the model, it will ask you what is the soil subgrade reaction. Subgrade reaction. It will ask you that value you have to fill up. Anybody know it? What is the meaning of soil subgrade reaction? Tell the answer. It is in kilonewton per meter square per meter. Anybody can tell what is the soil subgrade reaction meaning? Tell me fast. What is the soil subgrade reaction means? No, don't give equal projection. If you give equal projection, CG will shift. You can give load more means little more projection, little later. Tell me, what is the meaning of soil subgrade reaction? Tell frankly, you are knowing or not knowing? What is the meaning of soil subgrade reaction? That value you have to give to what? Software. Then it will consider the what? Settlement of soil, and it will give you exact pressure by finite element method. So, what pressure we manually calculate, P by A plus or minus M1 by Z1 plus or minus M2 by Z2, that also it will do. But our value and software value will slightly vary, not too much variation. Slightly it will vary, but remember, slightly it should vary because we don't consider settlement of soil here. Software considers settlement of soil when you give soil subgrade reaction. Soil subgrade reaction, you have to give input. If you don't give input, it will not run. It will tell sorry, missing data, I am not running. It will tell sorry, it will strike, it will tell no. Unless you give that value, I will not analyze it. So therefore, in the case of footing, when you see here, you get the pressure today. See, today pressure will come P by A plus or minus M1 by Z1 plus or minus M2 by Z2. Correct? That theory is not perfectly correct. That is correct if the soil is unyielding. When the soil is yielding, because of the differential settlement, pressure will vary. Therefore, that linear variation will not come. But remember, too much error will not come. So, anyway, why we bother? Those people, all of us, when we go to software, all of us means me and those who are in the ETAB batch. When you go to software part, there I will tell you, remember, our theoretical value has limitation. By mistake I told start. what you get by ETAB and SAFE, it is the correct value by finite element method. Therefore, you can depend on it, and there it will tell you pressure by contours. By color it will tell you. Directly if you see, it will tell you maximum pressure. How much? 190. Oh, safe. SBC 200. If you see here, minimum pressure. Okay. It will tell no lifting. Thank you. Over. Now, just curiosity. Anybody know here what is soil subgrade reaction? Charging is, charging is completely on. Charging is completely on. Nothing to worry. It is completely on. Because charge was lesser. It was only 11 when I started. So I never removed the charger. Thank you. So at least today you are more careful. Not like earlier. Thank you. Always remind me. Soil subgrade reaction, I can give only brief hint. Okay, tell me. Frankly, others, do you know what is soil subgrade reaction? Answer fast. There are so many are here. See, so many are not commenting. Tell me. Do you know what is soil subgrade reaction? If you tell you know means, I will keep quiet and explain later for ETAB and SAFE batch. If you do not know, I will briefly tell it. You think about it. No. So, right here. I'll take a small break now because I am non-stop talking. 5 minutes break I require. Just I'll sit somewhere there. I am in downstairs only now. I change the position. So I need around 5 minutes time just for rest. So that much time you think. If you leave the class, come back once again. Maximum 5 minutes. Little water I will drink and 5 minutes I will sit there. Okay. Now, soil subgrade reaction, I put the unit as kilonewton per meter square per meter. But in software, it is written kilonewton per meter cube. See, tell me, correct or not? Actually, it is not density. It is not kilonewton per meter cube. In the software, it will tell me in kilonewton per meter cube. Even though software will ask you in kilonewton per meter cube, it is actually kilonewton per meter square per meter. So, if it is kilonewton per meter square per meter, will it become kilonewton per meter cube? Tell yes or no. This I will not tell in what? In ETAB class. In the ETAB, because this is ETAB class only. I will not tell once again. So, kilonewton per meter square per meter. Clear? Tell me. It is kilonewton per meter cube, correct. But technically, kilonewton per meter cube gives you wrong concept. Actually, it is kilonewton per meter square per meter. Tell me. Clear or not? Yes. Now, anybody can tell me what is soil subgrade reaction, or shall I tell it and take break? So you can think about it. Shall I tell it and take break? I will dictate by words. I won't write on the board. Slowly I will tell. Soil subgrade reaction is the pressure required for unit settlement. Or if you tell soil subgrade reaction in kilonewton per meter square per meter, it is what is the pressure required on soil in kilonewton per meter square for soil to settle by 1 meter. For soil to settle by 1 meter. Now, I will tell us clear now. How much is the pressure you require on soil in kilonewton per meter square so that soil will settle by 1 meter? Remember, if the soil settles by 1 meter, can you survive? Tell me. If the soil settles by 1 meter, can you survive? Can you survive? If the soil settles by 1 meter, can you survive? Can you think the building? Tell me. No. So, soil subgrade reaction will be very, very high. How much value? I will tell you in the, actually, I will tell you in the soil report, you get it. Or I'll give example. For example, see, suppose for area of uniform pressure, see, area of 2 meter by 1.5 meter, if we apply a load of, for example, uniform pressure, apply a load of 1500 kilonewton, just example, suppose you apply a load of ಜಾಸ್ತಿ ಆಯಿತು, for example 3 meter by 2 meter ಇರಲಿ, 2 meter, if you apply a load of 1500 kilonewton and if settlement of soil is found to be the soil settlement found to be, say for example ಒಂದು 20 millimeter, imagine 20 millimeter soil will settle, it will come down by 2 centimeter. You tell me what is the soil subgrade reaction. Remember now this is required only for ETAB batch, not for RCC batch also. Why? It is only when you find the pressure by software, otherwise we don't consider. So even RCC batch also, that's all. But those who are in the ETAB batch, I will tell at that time how much value usually people give for soil subgrade reaction. Now tell me, a footing slab of 3 by 2 meter, you apply a load of 1500, you test it, you find that soil settles by 20 mm. I want the soil subgrade reaction. Okay, I'll take a break, you tell the answer. Okay, let me see how many will give the answer. I got the answer. I know it. I can't forget now. I got the answer. I will write somewhere here. Why? Sometime people will tell, maybe sir is not knowing. I not know the answer. I got it. I got the answer. Now, I will go and take 5 minutes break. During that time, I will observe the display. I will see the chat box. I will see the chat. Let me see who is the first to give the answer in kilonewton meter square per meter. Answer. Let me see who is the first person to give the value of soil subgrade reaction. I see I am not taking calculator now. The moment I see that answer, I will type yes, correct. Otherwise, if I keep quiet, it is wrong. Okay. 12,500 kilonewton per meter square per meter. Perfectly correct. Congratulations. Correct. Answer is 12,500 kilonewton per meter square per meter, or in ETAB and SAFE you type 12,500 kilonewton per meter cube. Perfectly correct. Congratulations. Okay, I take break. Others, you try to get this answer. It's a wasting time. Now I won't take the chat box. Why? I know the answer now. I got 12,500. Easy to remember. 12.5. Because 12.5, 25 are my favorite numbers. Why? If the beam span is 12.5, my reaction comes round number. If I take 12 meter span, I have to adjust the loading so that children will be eliminated. 12.5 is a guaranteed number. 10 also good number. 5 good number. 8 gives you very high decimal. 3, 6, 7, etc. gives you big number. Rounding off error will come. Okay. I will take 5 minutes break. Get the answer. Okay, I will start now. Hope you got the answer. Good. And remember, when I take software, there I will tell you how much you have to give. There is a thumb rule is there. Actually, if you give higher value, I will tell you how much there. So that little this side, actually it comes in the soil report. Or in the class, there is no soil report for us. I will prepare a report. What I will write? SPC so and so. And subgrade reaction so and so. I will tell that much. Density I will give you. So that is my own soil report by somebody who does not know too much soil mechanics. So there, I will tell you further. So today, okay, you got the answer. Shall I continue now? No more discussion. No more discussion about soil subgrade, because why? It is only for software batch. Yes, okay, I will continue. Okay, now we will go for the practical design of combined footing, the most popular beam and slab type. Remember, purpose is one design example thoroughly to understand, and then I will see that ends are sagging, center is hogging. One second example I will take, finish in one class only, full will sag. Reinforcement detailing I will tell you in the class, so that later in ETABS&SAFE you should not ask, sir, bars to be continued up to where? What you are doing on that day. Remember, there is a limitation. Okay, see, start. Now our question. I will write the question here, later remove it. Tomorrow when I continue, when I ask data, give immediately. Do not delay unnecessarily, because I cannot remember. See, there are two columns. There are two columns. Say column size is, one of the column is 230 or 200, I take 200 only, most popular. 200 millimeter by 600 millimeter, one column, and other column is, I will take 300 millimeter by little bigger, 700 millimeter. Okay. There are two columns. Now, how it is placed is here. Data. I am not telling beam and slab type. We don't know. Only plan I am giving. See, column is placed like this. Other column is placed like this. Little bigger. Okay, this way. This is the first column of 200 by 600 millimeter. This is second column of 300 by 700. For this column, I write here now, for this column, axial load is 1 nimisha, or 12. I should give the axial load so that someone should not laugh later. Nobody will laugh. If they laugh, I know how to make them weep. I will use M25 concrete and FE 500 steel. Don't remember now. Next time don't tell wrong values. Some will tell FE 415. It happened earlier. You take a screenshot of the question. If any corrections are there, I will tell you. So take a screenshot in a paper, write data. Suppose I change the data, you change and tell me. Okay. Then axial load is, first column is 1100 kilonewton. Second column load is 1400 kilonewton. Okay. Now, also I am taking quite good load for a building of around ground plus 3 or 4. Remember, not very, if it is only 1 floor or 2 floor, load will be lesser. I am taking quite heavy load. Also, see, actually when you solve by software, different combination will come. For one combination, these are the loads. For one more combination, one more set of load will come. And I will give couples or moments. It will keep on changing. One case it may be this way, one case it may be this way. And this way moment can interchange. What software will do is, it will design for all the cases. You will be stunned to know. If you design all the load combination manually, To finish one combined putting, it may take you around 60 days. Per day, minimum 8 hours. If you work manually, 8 hours per day if you work, 2 months it will take to complete the manual design. If you want to cover all the combination, dead load 1.5 DL plus 1.5 LL, 1.5 DL, 1.5 DL plus 1.5 EQ, 1.5 EQ how? 1.5 EQ this way, 1.5 EQ this way, 1.5 EQ this way, 1.5 EQ this way. Then 1.2 DL plus 1.2 LL plus 1.2 EQ this way, 1.2 EQ this way, once this way, once this way, once this way, once this way. People will collapse. They will become mad. Each and every time your pressure variation will come like this or like this. And designing for everything, you people will become mad. But don't worry, we will take up one of the cases. Now, what software will do is, in a split second, it will design everything, and result it will give you, steel it will give you, which tell me, it will give you which steel? Tell me if possible. It will give which steel? Minimum requirement or maximum requirement? Tell me. Software will give you steel, minimum requirement or maximum requirement? Minimum requirement or maximum requirement? It will give steel. It is called what? Envelope. It is called envelope, combining all the load combinations. Tell what? Software will give you maximum critical design, it will give you, or check for punching shear. It will check for punching shear for each and every combination. If you ask the software, 8 hours per day, 60 days, I am almost becoming mad. Are you mad? No. I just now started that 10 seconds earlier, finished. It will do one thing. See, it will tell, how it will tell is, when you tell analyze, it will tell one wave, one jerk will come. Jerk means yes, over. Suddenly display will come. And design also, same way, design you tell. Within no time, it will give design. Design will take lesser time, analysis will take more time. See, in ETABS&SAFE, Start Pro I am not telling. Design analysis will take around 1 minute. For a building of, say, for example, ground plus 5 or 6 or 7, analysis will take all the load combination, each and every column, each and every beam, each and every slab. We will not finish in 1 year. In our lifetime you can't finish it. In our lifetime you can't finish it. First of all, one frame analysis, it will take years together for you. No. All that analysis, software will take around 4 to 5 seconds. See, it will tell chakra, you know, net problem, that wave comes. It will, see, slide, it will turn this way, then suddenly give the answer. Design, it will give in split second, say 0.1 second. Anybody can tell why software takes more, 4 or 5 seconds? Are you calling more? It is, see, I will tell, analyze. It will tell, yes, over. Design, over. You tell design, over. Anybody can tell, but more I will discuss in software class. Why it takes more time for analysis than design? Anybody got the idea? Tell me. Anybody got the idea? Why it takes more time for analysis and very fraction of a second for design? No, not iteration, because analysis by finite element method, number of unknown will be in lakhs together, not lakhs of unknown. So, see, finite element method, each and every node, it has to find displacement. Number of unknown will be in lakhs. For a very big building, it will be in crores. So, it will take 5 to 6 seconds. Design nothing, it is a programmed one. Design is a program, there is no analysis, no finite element method. As per program, design, it will tell design, analyze. Yes, done. That way. Clear? This question you can ask anybody. Why it takes more time for analysis and very fraction of second for design? Clear now? Analysis, number of unknown displacement comes. Horrible it will be. You by FEM, all of you, almost so many have finished MTech here. All of you thoroughly know FEM? Yes or no? I think all of you are having very good knowledge of FEM. Tell frankly, all are having beautiful knowledge about finite element method and also matrix method. In finite element method, no, the person who wrote the procedure, he just copied the formula. That's all. No, the person who invented the method, he is the real genius. The person who invented the method. See, for example, Hardy Cross, yes, genius, we agree. He has given moment distribution method and also column energy method. And Jasper Kani, yes, we very much use finite element method, works on matrix method only. Finite element method works on matrix method only. Okay, leave it now. I will go subject now. I don't want to deviate. Yes, in water supply, some pipe network also, there you get distribution factor. Yes, that also moment distribution method. Actually, my level of structure analysis not bad. You know it. Regarding indeterminate structure analysis by MD method, SD method, Kani's method, or matrix method, or finite element method, my knowledge is reasonably good. Those who came to my class, they will be knowing how good I am. Okay, don't worry now. Anyway, for information, I am planning now one batch I am thinking of doing for, not in YouTube, for finite element method. I am thinking because so many people want FEM for their project, or they want FEM for so many things in complications. So I am thinking, why not? I have to arrange the time. It will be slow, lengthy class, not regular class. Weekly once I will give you. Not crash course. Weekly once. I plan around 3 hours class per week. Weekend, Saturday or Sunday sometime. There, I am thinking of making a batch for finite element method where matrix method also comes. Anyway, I will make announcement. I will prepare a demo class for that one and give a brochure. Not now. Because so many asked me earlier, sir, FEM helkodi inta. I told wait for some time. I am preparing, thinking of doing a batch, a memorable batch for FEM. Yes, moment distribution method is called successive approximation of slope deflection method. That's all. Further I won't discuss. Okay, I don't know. Leave it. Okay, now further see. Question. This column load 1100, that column load 1400. Further, this column has got a moment like this. Clockwise I will write. Here I will write anti-clockwise. This is lengthwise of 80 kilonewton, 80 bada, jasti mana, namge, of 100 kilonewton meter here, and here this is 140 kilonewton meter this way, and see, load 1100, and also here clockwise. Looking from this side, there is an anti-clockwise moment of, suppose thumb is not 45 kilonewton meter here, and here a clockwise of 75 kilonewton meter here. This is the result for one of the load combination. Over. Now, SBC of soil is 200 kilonewton per meter square. Subgrade reaction, today I do not want. Later, remember, in the software class, I will take the same example. I will ask you, okay, I will do one thing. I will see my YouTube class, take the data and send in the group. It is not public. There, I will write in a paper and send you in the group there and tell this is the software model we are making for combined footing today. And I will tell at that time, if possible, or 1 week earlier I will tell. At least during this week, you refer that class and continue and understand and come. Okay. Now, this is a question. I may change any value if I want. Then, it is 750, 750, okay. I will change any value, 300 by, I will make 750 because 750 standard. 600 by 750, okay. Now, I may change any value later. If I change, I will tell you, go back to take a screenshot and write in a paper this question. And then, in case I change tomorrow, see, no, I want for some reason, I will tell you, instead of 1100, you take 1200, you change the question and tell me 1200. Okay, start. Now, remember, first note, time being, never bother what? Never bother whether it is only slab type, whether slab type or slab and beam type. Clear? Never bother. You just consider contact of footing with soil, that is on plan area of L1 by L2. I write here now, this is a plan actually. See, moment you cannot show this way. If you want 3D view of moment, see, I will show it here, those who want, little later. L1 by L2 with the soil on plan A, contact area L1, L2, and ensure PG maximum not more than SBC of soil of 200 kN per meter square, and also ensure PG minimum is not negative. Tell me, clear or not? First, clear or not? You never bother only slab type or slab and beam type. That all later. Clear? Yes, okay. How to start? So, don't ask me, sir, this is slab or beam. You worry later. Okay, now, start. 1 minute now. See, I will start now. Sorry. One important data, I missed it. I have to give it. Anybody can tell what? One important data, I missed it. Anybody can tell? That data I am setting now, so that I want sagging here and hogging here. I am setting it now. Later I will give one more question where it will come only sagging. That is in my hand. You don't bother about that one. Anybody can tell me what is the missing data? One ನಿಮಿಷ 6.872 okay, no, I will change it. I am setting the question now. You don't bother about these things. Sometimes people are curious, sir ನಮಗೂ ಹೇಳ್ಕೊಡಿ ಅಂತ. ಇದೆಲ್ಲ ನಿಮ್ಗೆ ಅರ್ಥ ಆಗೋದಿಲ್ಲ. ಸೆಟ್ ಮಾಡ್ತಾ ಇರೋದು ನಾನು. See, the spacing of the column, sorry, I forgot to ask you. I should not have told. See, when you design a building, spacing of column, see, when you reach footing design, you know the column cross section and also you know spacing of the column. It is already known for you. Tell yes or no. Spacing of column is already known to you. Yes or no? First. When you design, see, when you fix the column position, spacing is known. Yes, correct. Thank you. It is 5.3 meter or 5.2 meter is the spacing in the question given. So, I will read the question once again. Two columns, see, I will do one thing now, this I will remove now, or if you want to understand more clearly, see, there is one column here. Another column here, little bigger, okay. Placed like this. Here, this load is 1100 kilonewton, this load is 1400 kilonewton, and one this way and one this way of 100 here kilonewton meter and 140 here, and one this way of 45, one this way of 75. This is the arrangement. You can make a note. Here you cannot show it. These all I explained earlier. Again I'm wasting time. Okay. Question fully clear. The center of column is how much? 5.2 meter. Center of column is 5.2 meter. Or I change the data 5.4 meter because I first got 5.4 only. That is, the columns are 5 meter spacing is quite popular. In sometimes most popular spacing is 3 meter, 3.5 meter, nowadays around 4 meter, sometimes little more, 5 meter. As the spacing becomes more and more, column load will become more, that's all. Okay. Now question given, spacing is 5.4 meter. Clear now? Okay, now start the design. See, first you do one thing. See, this is your L1, this is your L2. Make a note. Okay, start. First, forget about all these things. Those who want to parallelly write procedure yourself, referring to what all I am telling, prepare your own procedure. See, first find area required in plan equal to, you can tell 1.1 times, okay, 1.1 times P divided by SBC of soil in the bracket considering only axial loads, that is P stands for resultant axial load, that is equal to P1 plus P2. If I call this 1100 as P1 and this one more load is how much I told you? If I call this as P1, if this I call P, or if I call PL and PL better, P1 P2. Symbol is not a problem. P1 P2, it is P1 plus P2, or P is the total load, total downward load, and also 1.1 because why 10% we consider 10% of P we consider as what? We consider as self weight of footing, including some fillings all. Tell me, crystal clear? This bit is not clear. Then what you are doing all these days? Crystal clear? 5.4 meter. I changed to 5.4 meter. The spacing of column, 1 minute now. If I make 5.4, any problem will come? Just 1 minute. I will check fast. I do not want unnecessary later changes. 1 minute. Okay. 5.4 meter is okay. 5.4 is okay. If requirement is there, I will change tomorrow. Okay, now start. This is much clear. Okay, but remember, therefore, substituting area required in plan equal to 1.1 times what? 1100 plus 1400 divided by SBC 200. Tell the answer in meter square. Fast. Tell the answer in meter square. Little fast. Don't make mistake today. Why? This is YouTube class. I do not want to change the data. Like my Zoom class, I can do whatever I want. At least one person. At least 2 answers required. 13.75 meter square. Okay. Now, very, very important. Tell what? This is the area required to get uniform pressure. This is possible only if the resultant column load passes through CG of the column for footing. And also there are couples. When couples are there, tell me what will happen? There will be additional pressure due to couple. Therefore, this I told you, considering additional pressure due to couples, due to moments. Which one? All those 4 moments. Due to additional pressure due to moments, let us increase the area. Increase area by, tell me some percentage. I told you, if you try small percentage, unsafe chance is there, pressure will go beyond SBC. If you high percentage, wastage will come. Some good reasoning percentage. Tell the answer. You propose. I told you. Sometimes 10, 15%, 20% sufficient. Sometimes even 40% also required. I will do one thing. I will go for 30%. Why? Little liberal. Okay, done. I will go for around 30%. Okay, 30% okay. Safer side. We do not want unnecessary revision later. Practically you decide. Okay, I will increase by around 30%. One more thing. See, suppose this gives little more area. Good. Why? Tell me. If you provide little more area than required, pressure on soil will become more or lesser. Pressure on soil will become more or lesser. Suppose you provide with a little margin. Whatever requirement is there, some tips are given. And then pressure on soil will increase or decrease. Tell me, pressure on soil will increase or decrease? Decrease. See, for safety of the building, if the soil, pressure on soil is lesser, it's a what? It is a good or bad? Safety point of view, confidence point of view. If it is your building, what do you feel? You feel comfortable or in tension? You feel comfortable. Okay. If space is there, you will tell, sometimes people will tell, ಕನ್ನಡದಲ್ಲಿ ಹೇಳ್ತೀರಿ ಒಂದೊಂದು ಅಡಿ ಜಾಸ್ತಿ ಹಾಕ್ರಿ ಅಂತಾರೆ ಕನ್ನಡದಲ್ಲಿ. ಹಿಂದಿಲಿ एक फीट ज़्यादा डाल दो सबको. English 1 feet extra, 0.2, 0.3 extra, give it. Safer side. Let the load be spread on more area so that settlement will become lesser. At least building safety. Okay, 30% more. That is, I will remove. That is, area in plan is almost equal to, tell the answer, increase by 30%. I will not show the calculation. Why? Somebody should walk out if I show the calculation. People should walk out protesting. Sir, you are underestimating us. 30% more you are explaining. You are wasting time. 17.88 meter square. 17.88 meter square. This will be equal to L1 into L2. Correct? Okay. Now, clear? This will be equal to L1 into L2. Okay. Now, very, very important. Do not go to right here. Do not go to that isolated case where you make what? this projection equal this projection. Don't make it here. That is not valid here. Here what you do is you put a rough sketch here. See, rough sketch here. One column here, out of scale. One more column here. This spacing is 5.4 meter. This is a given data. This is your PL. This is your PR from center, and this is your L2. This is your L1. Okay, start. Now, when you should write everything now. I am dictating. See, I am dictating now. See, right? We already discussed lengthwise bending to be minimized, or we want as much as lesser BM and SF. It is better to take PL equal to PR equal to 5.4 into number fast. 5.4 into number fast. 5.4 into number. Sometimes people will tell, "Ee tara idya, matte ide." So many people are not doing all these things. They will roughly fix the dimensions and check it. Number fast. But this is not applicable. Why? It is applicable only if the two column loads are equal and no couples are there. Only upward UDL is there. Around 0.35. Around 0.35. Answer. 5.4 into 0.35. Answer. 5.4 into 0.35. Answer fast. 5.45 into 0.35. 1.89. 1.89. Okay. This will be equal to what? 1.89. Therefore, your PL plus PR. Answer fast. This, if you make this all you have to write after when you go to recording, write statements all, because you don't depend on my only writing on the board. What all I tell, write it. So your PL plus PR equal to how much answer? Again, if I explain, insulting for you. PL plus PR equal to how much? 3.78. 3.78. Okay, now this column load is 1100. This column load is 1400. Oh, little more load there, less load there. Now, remember, bending more means, see, very important. One person long back, he knows subject. Of course, he has got good practical knowledge. He told me, see, your principle if you apply, what will happen is, projection will have a little more bending. Okay, but if you do other way of coinciding this resultant, I will tell how many load combination you do it. Different will give different combination. Okay, one of them. Then you can make the foundation little lesser. Then I told him, if you give little more area and give more contact area, suppose it is your own building, he will told, yes, that I will do. See, your building means what? You are careful. Others' building means you are not bothered. It is injustice. See, when it is your building, you will tell for the beam, put one extra rod. Why? You are staying in the building, slab thickness. He told 5 inch sufficient. No, make it 6 inches. See, your building. Somebody's building means, okay, the calculation came 5 inches, 5 inch sufficient. 3 bars are required, provide 3 bars. Your building, 4 bars. See, so be one thing. Others also treat like your building. So little more area, and if space is there, good or bad, he told good. In front of the cost of the site and building cost, this small extra for footing. Why? Number one for a building is footing. Equally important is what? Topmost rank for importance is what? Tell me. Footing. And equally top rank for which one? Both are very important. If something goes wrong here, you can't do anything. Column. Beam slab, if something happens, you can do repairing. Some rectification you can do. Column, and footing dangerous. Remember, therefore, little liberal. Then you will tell, okay, start. Now, this load is lesser, this load is more. So, judgment. See, 1.89 came, 1.89 came. I will reduce it slightly. Tell me why I am reducing. I will increase slightly. Tell why I am increasing, because higher load, I want more projection. Resultant load will come as near as center as possible. Resultant load will come to as near to center as possible. Exact it will not come, but stability comes more. They will tell, my building, I am happy. Yes, tell the answer. Don't change too much, no ratio. 1.89, shall I try 1.5? And then tell me, this number total is 3.78. If I make 1.5, tell little more here. How much you reduced here, that much increase. Answer. 1.5 here, there. These are all thumb rules. They see, everything I told, none of them is valid because it is not the ideal case. 2.28, or I can make 2.3 meter. Okay. Or you can make 1.6 meter. Other one, tell me. Or one more, make 1.6 meter. ತುಂಬಾ ಕಮ್ಮಿ ಮಾಡೋದು ಬೇಡ. 1.89 ಬಂತಾ? Okay, 1.6. Other one. If it is 1.6, other one. 2.28. Correct? ಅಲ್ಲ 2.28 ಅಲ್ಲ, ಕಮ್ಮಿ ಆಯಿತು, ಸ್ವಲ್ಪ ಕಮ್ಮಿ ಆಗುತ್ತೆ. 2.2 ಮೀಟರ್. 2.2 meter. Okay, I will take 1.6 and 2.2. So, write all these. I will finally take, I rub this one. Let us try PL equal to 1.6 meter and PR equal to 2.2 meter. Then, what is the total length of footing? L1. Tell me, full length L1, how much? This is L1. Then, full length L1, 1.6 plus 5.4 plus 2.2. Full length L1. First, full length L1, 9.2 meter. Okay. If that is 9.2 meter, tell me what is L2 required. Area required is L2. Oh, gone. Forgotten. Tell the answer. After 30% increase, what is the area you got? Who remembers now? After that 30% increase, what is the area you decided? What is the area we decided? After 30%, 17.88. Okay, 17.88 by L1 is 9.2. Tell the answer. 17.88 by 9.2. Answer. Answer first. 17.88 by 9.2. Width of footing. ಇಷ್ಟೊತ್ತು ಬೇಕಾ? 17.88 by 9.2. 1.943 meter. Okay. Round off. Now 1 now. 1.943 should be available there. Suppose little more available, no problem. Later, practically, suppose some problem comes for bending here, you can do one thing. You reduce the length slightly, later increase the width. That all I will tell you in the ETABS&SAFE class. How to adjust the dimensions. Okay, start. 1.943, I will take 1.95 meter. See, around 2, some will tell, sir, ಕನ್ನಡದಲ್ಲಿ 2 ಮೀಟರ್ ಮಾಡ್ಕೊಳ್ಳಿ ಸಾರ್. ಸಿ ಸಮ್ ಕನ್ನಡ ಕೊಡಿ ಸಾರ್ 2 ಮೀಟ್ರು. ಹಿಂದಿ सर 2 मीटर दो सर, 2 मीन्स दे दो, ये क्या चौकासी है, दे 2 मीटर. English, make it 2 meter, safer side. No, I will tell 1.95. You make practically 2 meter if you want. Okay, I will continue because I want decimal number there. I want decimal number there. 1.95. Therefore, see now, therefore, our trowel arrangement is But if I write here now, our trial arrangement is 1.95 meter, 9.2 meter, one column here, one more column here, spacing between the column is 5.4 meter. We have decided left projection of 1.6 meter and right projection of 2.2 meter. And now the question correctly reached to our raft footing plan. Yes or no? The question correctly reached the data given for raft footing. I told the L1, L2, I told the column position, I told column load, I told moments. Yes or no? But there 4 columns are there, here only 2 columns. It exactly coincided with the data given for raft footing. Tell yes or no first. First tell me, yes or no? There 4 columns. On that day, see, I took a platform, 4 bottles I placed. My brother helped me. You from this way, 4 column you are seeing. You from this way, you are seeing 4 column. Now, today, you from this side, you see 2 column. You from here also, you see 2 column. Exactly same. Therefore, now, show your talent and get PG max and PG min. Can you try in one day? One day time. Tomorrow till 5 p.m. time is there. You can try. Nobody can tell. If 4 columns means I know how to do it. If 2 columns, do one thing. Put dummy 2 more columns with 0, 0 and 0, 0. That nobody can tell. Now, can you try and tell tomorrow's class what is PG max and PG minimum? First. Anybody can tell tomorrow? Yes. But still, tomorrow, briefly, I will tell the replacement and PG max, PG minimum. In the group, give the answer. Only answer. In the group, give only answer. PG max, PG min. We will check tomorrow how much it is correct or wrong. But I won't announce that this person gave wrong answer. I won't announce it. Don't worry. But the group you can make out. Or if you feel I do not want my name to be discussed tomorrow means send me personal message. You send me personal message. Those who are in the group, personal message. PG max so and so, PG min so and so. Now, right, hope that tomorrow same answer will come. So that I will mention tomorrow, yes, yesterday or today morning, 3 people gave perfectly correct answer. Then I may announce the name. I will tell 4 people give wrong answer. I won't tell the name. Nobody will be knowing who is correct, who is wrong. Those who are correct, their name I will announce. Okay. Now, already 9:38, beyond the limit. We will start tomorrow, 5 o'clock. Okay. Thank you. I will continue the class. Today there is no problem. See, I prepared a dummy schedule there as extended class. Today it is not required. Tomorrow I will prepare 2 extended classes. Class number, today is part number 11. Part 12, then one more data ready there, live. Part 12 extended, I will prepare one more. Part 12 further extended. Why? If any trouble comes due to network etc., I will close and immediately send the, it is actually unlisted now. One I make public, other 2 I make unlisted. Then the moment I got problem, I stop the class. Tomorrow long class is there. We don't want to waste. I will immediately, it may require at least 10 minutes. I will take out the mobile from there. I have to make it public, and then all I have to do is send the link to you. A status I won't give. I may put in the status. But remember, those who subscribe or you are in the group, either those who are in the ETAB group or RCC, even still earlier group and BSK batch, they will get it. Other public, they have to see by notification or Tomorrow, see, when I go live, you can see there. I will put in the status also then. Okay, thank you. See you tomorrow. At least what all I told, study thoroughly. And remember, this type of explanation you will not get anywhere, I am sure. I am not telling, I am giving more experience, more explanation. You tell me a place where this much explanation will be given or is given. Tell me, I will also join that class. Okay, thank you.